this whole time.
Okay. All right. Okay, so live broadcast. So Sherry and I were talking about we liked lesson 4. It was a whole lot easier. How do you feel, Cassandra?
It was definitely way easier.
Yeah. So that's what I thought too. Although the Powerball thing threw me off. So I don't know about you guys, but that part was extremely confusing. I couldn't figure that out, but then there wasn't anything on the homework that said anything about it. So I was like, well, maybe we're off the hook on that one.
Well, and I sent him a couple of questions, and I don't know if either one of you guys can answer it for me. But when he did his video, he listed for the infomercial one. Okay, so for the infomercial one, he listed X is the number of views, then PX for your probability, then X times PX, and that gives you your mean, you know, your expected value. And then there was X minus MU squared. And I watched that video over and over and over, and he never said what that actually was. What is it that we're actually figuring out with the X minus MU squared? Did you guys?
I don't remember that one.
Like, I went over and over and over and didn't see it. But the difference was in the preparation assignments and in the homework, there isn't the X minus MU squared. It's the X minus U squared times PX. And that gives you the sum variance where you get your deviation. I'm just confused as to why it's separate, why there's two separate ones.
Okay. Megan just
Megan.
joined us.
Hello?
Hello.
Hello.
Okay. So Sherry, why don't you restate that for Megan? Maybe she might have Hello. She might have a better answer for you.
Okay, Megan, can you hear us? I don't know if she can hear us. Megan, can you hear us?
Yeah, it's very quiet. I think I might see if my earbuds work. Okay, try that again.
Okay. Is that better?
Yes, it is. Sorry.
Okay. So my question was, and I emailed Brother Balls about it, was when he was going through his video, he listed, okay, for the probability for the one with the infomercial, okay, he had X, he had the probability, he had X times PX, which is the mean, and then he had another column, which is X minus MU squared. What is that? What is, you know, what is it we're finding out there?
I need to try.
Give me one moment. I'm still pulling everything up.
Okay.
You guys are on lesson 4, is that correct?
Correct, yeah.
Yeah, but she's talking about a video from previous.
No, this is this week's video.
Oh, okay. Never mind.
Okay, I haven't seen that video. I'm trying to remember what that is. The mu x squared?
No, it's X minus MU squared.
X minus. I'm not sure. I'll have to look into that and I'll get back to you. I'll send you an email or something.
Okay, I just couldn't figure out. He only does that in the video, but in all of the other homework, it doesn't follow that same, like, he doesn't
Pattern.
have that. That's not the of them. It goes straight from where the mean is to the X minus U squared times PX.
Gotcha.
And so when I'm taking notes, and I go to use my notes for the homework, and the homework is different than what he's done and what's in the book. The book doesn't follow that same one either. So
Okay.
I just want to make.
Yeah, I'll look into that, and then I'll send you an email hopefully later today.
Okay, great. And like I said, I did email him as well. I just wasn't sure if that was something that you would have any idea what I was talking about.
Not off the top of my head, sorry.
Okay. Okay, did you guys have any other questions about lesson 4?
No?
No?
All right, so we ready to start the group quiz?
Yes.
Yeah.
All right. Sherry, let us know when you're in, because it seems like your connection was always just a little bit behind.
I know. I'm not quite sure why. Mine's very thoughtful. Okay, I'm in.
Okay.
Okay.
All right. Are you ready, Cassie?
Yeah, I'm ready.
Okay. All right. Give all your probability answers as decimals. For example, 0.1234. Do not give probability answers as percents. All right. So the human blood can be classified into one of our basic types: O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table. Okay, use the data to answer the following questions. Okay, so the blood types and the proportions given in the table above define a probability distribution.
What types of proportions? No. That's not accurate, is it? Oh, yes, actually it is. The probability. Yeah.
Yeah, proportion is probability.
Okay. What is the probability that a random selected person in the United States has O blood? So 0.45, correct? Which will not have O type blood. 0.65.
It would actually be 0.55.
0.55?
Mm-hmm.
How did you get the
Oh,
0.55?
yeah, sorry. 45
Because,
plus 55 is 100.
Yes.
okay, so 0.55. So it's counting all the people that aren't.
Mm-hmm. Or 100 minus 45.
Right. So,
Okay.
all right.
So number 5, what is the probability that a randomly selected person will not have type O blood?
That's the one we just did. That's the 0.55.
I thought that one
No.
was 4.
Yeah, that one's the 0.45. So, because it's saying not.
Sorry.
Okay. So did we decide that number 3 was true?
Yes.
Okay. Okay, so 4 is 0.55 and number 5 is 0.45?
No, I think it's flipped.
They have O blood as 0.45. because that's what it says in the chart.
Right.
And then they do not have 0.0 blood is 0.55 because that's 1 minus 0.45.
So 4 is 0.45, correct?
Mm-hmm.
Okay.
Yeah, that's what I have.
Does that make sense?
Yeah.
Okay.
So it's
All right. So we're moving on to number 6.
Yes.
yeah.
All right. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. To angle one of the dogs demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Answer the following questions. So if the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? So we round the decimal to 3 points. So, so we have 7 bowls. So it'd be 1 divided by 7.
I've got 0.1428, so it'll be 0.1423. Does that sound right?
Yep.
Okay. So 0.423 is what you said?
0.1423.
0.1423. Okay, so it's only 3, round the answer to 3 decimal points.
Oh, I'm
Yes.
sorry, 1/4. I'm sorry. Get rid of the 3. It should be the 2. It should be a 3. 0.14.
Okay, so 143 or 142?
Right.
143.
3.
Okay, 143.
Okay, so number 7. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dog would do this well by random chance alone. Which of the following statements is most appropriate?
This provides strong evidence the dogs can do.
What percentage is that? Yikes. I would say, well, just because it says it's very unlikely that the dogs would do this well by random chance alone. So I would think that it's saying that this provides strong evidence that the dogs can detect bladder cancer. Does that sound right?
Well, nothing's done by chance or by random. So, and it takes time. So it's a long-term pattern, and it's not predictable.
Right.
So because by like if they were just to choose at random, it would be 0.143, and whenever they actually do it, the rate is at 0.407, which is
Right.
pretty, good.
That's stronger. Yeah.
It's much stronger that it's not by chance.
Okay. So we'll go with the first one.
Right.
Okay. M&Ms are small chocolate candies. The M&Ms website previously indicated that in the United States, the distribution of the colors in the bag of plain M&Ms is given in the following table. So if you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy?
0.13.
So if drawing just the red, so you have 1 out of, I guess they're not counting the green since it's zeroed out, even though there are green in there.
No, I think it's zeroed out because we have to figure that out. It's 0.16. Problem number 9 is.
So they're still use
Okay. They're
green
still
to
using
figure out the red.
So it's 1/6.
Right.
So it'd be 1 or 0.167.
No, just 0.16 because you round to the 2 decimal places.
Oh, 2. Okay. Okay.
And then
1/6.
number 10 is going to be 0.84. So it's every number but the green.
Okay, so what was 9? What's the probability of randomly selecting the green?
0.16.
Okay. And then the red is the 1.3,
Mm-hmm.
Yep.
Or 0.13.
0.13.
that thing. Okay, so what was 10 again? What's the probability?
0.84.
0.84. Okay. Okay.
All right, so number 11, the ACT scores of students admitted to a medium-sized public university in the western United States were taken from Capix.com. The following summary statistics were calculated. Use the information from the public university to answer the following questions. Half of the observations are less than or equal to what number?
Is that the median?
It would be the median.
Okay, what I thought.
Okay, so the median is 24. 1, 2, 3, 4. Maximum is 35. Minimum is 14. I think they're oh. Observations are less than or equal to what number? Okay, so yeah. So Sherry, are you saying that? So Sherry, are you saying that that's
24.
yeah? Because look at what the mean is to the median. So it's going to be almost. It'll either be less than that or it's going to be equal to that.
Oh, yeah, 24. Top 25 scored above what number? Above 27. So number 12 would be 27.
Yep.
Yeah.
Which constant length is not one of the 3 rules of probability? Okay. I would say, I don't know if we all have these in the exact same order or not. So the answer should be, if the probability is high, then the probability is positive. If the probability is low, then the probability is negative. We know that that's not
Yeah, because it can't be negative.
right.
So for me, it's the
Yeah,
third one.
Some of the probabilities. Right. Same with me.
Yep, me too.
Okay. So 11 we got 24,
There's
and
the-
12 we got 27, and 13 it was the third one. It
Correct.
can't be negative.
Right.
All right. So is everybody good?
Don't do well on this test. Yep,
Yeah.
I think so.
Okay.
Yep, that was it. That was all of them. Okay.
Okay.
That's it.
Awesome. Now, Thursday, what time works for you, Cassie?
Thursday, anytime before 12 because actually no. Yeah, Thursday anytime before 2 should work.
Anytime before 2?
Mhm.
Okay. Should we do 10 again, Sherry, or?
Well, I'm just wondering if we should go earlier, just in case Kaylee has to work like she did today. I
Yeah.
kind of think the earlier the better, because when we signed up for the thing, it was for the early one, so maybe that is what works best for her for work. So even if we could do like an 8:30 or a 9.
Okay.
I don't know.
So do you want to do 8? Does 8:30 work for you, Cassie?
Yeah.
Yeah, that works.
Okay. I'll put it in for 8:30.
Okay.
All right. We'll see you Thursday at 8:30.
You guys seem to be doing great. If you have any other questions, feel free to email me or come into office hours. I'll probably meet with your group again.
Into your office hours.
Oh, there's just a link. Here, I'll post it on the chat real quick. So if you want to just like save that, that's going to be the link for it for the rest of the semester.
Okay.
And then,
Awesome.
yeah, I'll meet with your group again probably about halfway through the semester once I've met with all the other groups at least once.
Okay.
Okay.
And you guys are doing great.
All right.
Okay.
Thanks, Megan.
Thank you.
No problem.
Okay.
All right, guys. See you Thursday at 8:30.
Bye.
Bye.
Right.
Okay.